Now that we've authored a very simple application, I want to deconstruct the code in the program file, because Visual Studio added a lot of stuff to get us started that we don't really know what it is yet. So I'm going to walk us through this code step by step and show you all of the pieces and parts that Visual Studio put in and explain what they do. Before we get started though, I just want to show you a high-level overview of how we write an application in C#. First, we're going to use our programming tools, or IDE, which stands for Integrated Developer Environment. Visual Studio is an IDE. All it is a piece of software that helps us to author code. And it streamlines common tasks like compiling our code, handling errors, creating classes. It even has project templates like the console application, which gives us a good starting point for our application so that we wouldn't have to go out and create our structure on our own. Visual Studio allows us to produce our custom code. And this is the crux of what it is to be a programmer. We're going to be creating objects in C# and giving it commands that do things that are important to our application. For example, if we were creating an application for a bank, we would be writing a lot of custom code to manage bank accounts. How do we deposit? How do we withdraw? What kind of data, like balances and account numbers, do we need to keep track of? How are they stored? Who can access them? All of this comprises our custom code that we create in C#. However, our custom code is going to use or reference code that was written by other developers. And there's two places we can get code from. The first is the base class library. The BCL for short is a bunch of classes in the .NET framework that were authored by Microsoft. And these classes do a lot of useful, common tasks for us. And all we have to do is reference them to use them. In our Hello World application, the console was a class written by Microsoft, and it handles interacting with the command prompt. If we were writing an application, it would be a huge waste of time if we had to figure out how to read and write data from the console. It's a common task. Every console developer wants to be able to do that, so it's included in the .NET framework. And as we'll see later, the .NET framework has a whole library of built-in classes and functions that can make our work easier. There's also third-party class libraries. We can download open source code or even purchase code from software vendors that we can include in our project to automate common tasks. A good example of this is working with Microsoft Office. There is a whole library of Office utilities out there that if we install in our project, we can automate working with Excel and Word and Access through our C# code. So all of these libraries mixed with our custom code is what makes our application. And Visual Studio will build or compile this code into a finished product. And the finished product can be an EXE, which stands for executable. That's a piece of software you can run. A DLL, that is Dynamic Link Library, and it is also called a class library. A DLL is code that can be used by other applications, so it's only for sharing code. You can't actually run a DLL. It has no user interface. It's meant to be consumed by your code to do tasks that are pre-built. And then there's some other file types that Visual Studio can create, but in the interest of being a beginner's course, we're not going to go into those. All of this compiled code is then run by the Common Language Runtime, or CLR for short. The CLR, think of it as a sandbox that your application goes into when it runs, and it allows the .NET framework to manage your memory, decide what happens when you start and stop your application, and what should happen when errors occur. The CLR is kind of the overseer of what goes on in your application. So let's begin by looking at the top of our file. We'll see here a bunch of using statements. These statements denote namespaces. And namespaces are a way in C# that we separate code into groups. They tell C# where to find classes that we want to use in our program. The namespace that's most important in our program is the system namespace. System is where the console class lives. So if we want to use console to read and write, we have to include the system namespace. So using system allows that match to happen. There are thousands of classes in the .NET framework, and the way that C# knows where to look for them is by putting a using statement at the top. Think of a namespace as like a path in a file system. So using system.collections.generic means make available all the classes from that path. If we were to remove all of our using statements from the top of our file, the console object would turn from teal to black and it would get a red underline. That means that C# has no idea what console is, where to find it, or how to use it. Classes in Visual Studio are always going to be colored cyan, so they're very easy to spot. We don't necessarily need to put the using statement at the top. We can fully qualify the namespace. As you can see here, if we put system.console.writeLine, now C# knows where to find the console class. It's in system. The using statements provide us a shortcut so that we don't have to do all of that typing every time we want to use the console. So namespaces are shortcuts. The using statement also makes classes unique. With thousands of classes in the .NET framework, inevitably we're going to name something with the same name as something that exists in the .NET framework. And as long as we reference our namespace instead of the other one, it will know to use our class instead of the one that's built in. If you ever come across a situation where you have a class named the same as a class in a namespace and you need to use both of them in the same file, then you must fully qualify your namespaces. Regardless, the take-home point here is that if you ever try to use a class that you know exists, and you get a red underline that it's an error and can't be found, it's almost always because you forgot a using statement or you spelled the class wrong. One of the next questions my students usually ask is, where does system come from? We know it's in the .NET framework, but where is the .NET framework? And the answer is that the .NET framework is installed into your Windows directory. I've got a little snapshot of my Windows directory on my Windows 8 machine. It's a similar path on other versions of Windows. But if you open your Windows directory, go to the Microsoft.NET framework, and whatever version of the framework you're on, at the time of this video, the framework's in version 4, you can look at that folder and you can see many DLLs. And when I said there were thousands of classes in the .NET framework, I wasn't joking. If you scroll through all these DLLs, eventually you're going to find the system DLL, and that's where the console class lives. So whenever you put a using statement at the top of your file, you're usually referencing one of these .NET framework libraries, or a library that you've written or a third party has written. All of the .NET framework libraries are in your Windows folder though. The most common ones are referenced in your project for you. Later on in the course, we'll show you how to add references to some of these DLLs that aren't included by default. You usually only use a subset of the .NET framework. So by default, Microsoft only includes the most common and necessary DLLs into your project. But if you have need for the other ones, you can quickly and easily add them in Visual Studio. Now that we've discussed namespaces and the using statement, we can move down in our code, and the next thing you're going to notice is that our code has a namespace as well. Our namespace is helloworld.ui, and this is pretty typical for .NET projects. Whenever we add classes, the default namespace is going to be named after the project and then the folder path that the class is in. Now, program is in the root of the application, which means it's not in a subfolder. So in this case, the namespace is the same as the name of the project. Now this is just a text field, We're actually allowed to modify the namespace, so we can take out helloworld.ui and we can put in whatever we like, but this is not very common to do. After the namespace declaration, we have curly bracers, and I colored these yellow in the diagram because this is a very important concept in C#. Anything that exists between curly braces belongs to the containing statement. So in this case, we have namespace helloworld.ui, then a set of curly braces. Anything between the yellow, in this case the class program, belongs to the helloworld.ui namespace. We call these bracers code blocks. Dropping down into our namespace's code block, the next line is a class definition for a class called program. A class is a custom type that we as programmers create, and it's really the foundation of object-oriented programming in C#. Get used to seeing the syntax because you are going to be creating a lot of classes as a developer. Classes are what we use to represent ideas in code. So we'll create classes for customers, bank accounts, books, authors, whatever it is that our system is intended to model will be divided into logical classes. In this case, for our Hello World application, Visual Studio created a class called Program, which represents the program that we are running in the console. Again, we see another set of curly braces. This code block contains what we call the class members. So there is a method called main that exists inside the class program. Main belongs to program because it is contained within it. I referred to main as a method. Methods are the verbs of programming. They're groups of statements that are performed to accomplish a task. These statements are usually tightly related. We make sure to name our methods to be very specific. Like, for example, in a bank account class, we may have methods to deposit and withdraw money. Those are two actions that a bank account would be able to do. These methods are useful for meaningful groupings and code reuse. Once we define a method one time, we can call it many times throughout our code. Again, the main method has curly braces, a code block, to contain the code that needs to be executed when main is run. Main is very special in a console application. This is where the program starts. If you were to delete the main method out of the console application, your program would not run. The two lines of code that actually do the work in the main method are called statements. In C#, statements typically end with a semicolon. Before we wrap things up, I want to show you some of the common namespaces which are available in the .NET framework. As I mentioned before, and I'm going to say it again, there are thousands of classes in the framework to help us do things. But these namespaces tend to be the most often used for data-driven business applications. The system namespace we already introduced briefly. It contains all of the base data types, numbers, text, date, error handling classes, and console interactions. System.collections has classes for dealing with groupings of data. Oftentimes in an application, we're not going to work with just one customer. We're going to work with a list of customers, and collections has a lot of classes to help us do that. System.data has classes for dealing with databases. So if you're going to use SQL Server, Oracle, or some other data-related activities, System.data is going to help you out. System.io is for reading and writing files and other data streams. So if you have a flat file of text or a comma delimited file on the disk that you would like to process, System.io has classes to help you out with that. System.text is all about working with text data. Not a big surprise there. System.timers lets us perform actions at regular intervals. So if you had an application that you wanted to do an action every 5 minutes, System.timers has events to allow you to make that happen. System.web is huge. It has all sorts of goodness for working with the internet. You've probably heard about ASP.NET, MVC, those types of things. All of those live in system.web. And lastly, system.xml is for reading and writing XML data. If you've never heard of it before, XML stands for Extensible Markup Language, and it's a common format for sharing data between systems. In conclusion, Hello World, very simple application. There were a lot of key pieces going on in that file, though, that made up a working program. Namespaces, they tell C# the location of the code elements we want to use. We put them inside a using statement, which allows us to work directly with the named elements. Without it, we must fully qualify or write the whole path to the element. A class is what we use to organize code into logical groupings. Classes are the nouns of C#, and they model real-world concepts. Again, if we're writing a banking system, I would expect to see classes like account and customer. Main is a special method for console programs, and it's the entry point of the program. Anything in the main method is going to run first. Curly braces set up code blocks, and those tell C# where related code begins and ends. A common mistake for people just starting out with C# is to open a code block and forget to close it. The second most common mistake is to forget to put a semicolon at the end of your statements.